비디오를?
Okay, not anymore. Okay, so here we go. You're asked to find the area of these three shapes. I went ahead and what do you call? I plotted them in order to save time. So the rectangle here, to find the area, there's two ways of finding the area. Okay, if possible, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so forth. But nobody wants to do that. Or you can find the area by counting the number here, the length, and counting the number going up and multiplying those two. It's just a shortcut. So over here we have 1, 2, 3, 4, 5, 6. So the length here is 6, and the height 1, 2, 3, 4, 5, 6, and it's also 6. So the area of this particular shape is 6 times 6, which is 36 units squared. Let's do the trapezoid. The trapezoid over here, you hopefully remember, h b1 plus b2 over 2. Now, you've got to look sideways, okay? So here would be b1. Let's just call this b1. So it's 1, 2, 3, 4, 5. B2 would be this one. 1, 2, 3, 4, 5, 6, 7, 8. And the height is this, the distance between the base 1 and base 2. So this is your height. Okay. And the height would be 1, 2, 3, 4, 5, 6. All that divided by 2. Alright, so 5 plus 8 is 13 inside the parentheses. And I'm going to multiply 6 times 13 and then divided by 2. 6 times 13 is 18, goes 1. 78 divided by 2, and 78 divided by 2 is 39 units squared. Okay. Triangle over here. Area of a triangle is area is base times height divided by 2. Let's see if you can recognize the base. So again, just look sideways. Okay, so again, this is your base. The base is 1, 2, 3, 4, 5, 6. So the base is 6. Your height is this distance from the very top here. That's your height. And the height is just 2. 6 times 2 divided by 2, or 12 divided by 2, and just 6 units squared. Okay. Let's move. Points A and B represent two vertices of a right triangle. Which coordinate represents the third vertex C of the right triangle? So you want to make a right triangle. So let's go to the points. 6, 2. 6, 2 will be here. Well, if you join all these three, would that make a right triangle? No, so that's not it. Negative 4 and 5. Negative 4 is here, and 5 is up. 1, 2, 3, 4, 5. You put a dot there. Would that make it a right triangle? Definitely no. Okay, you can definitely see that's not a right triangle, so that's also out. C. 0, negative 4, so 0. Don't go left, don't go right, but go down negative 4. And if you join this, would that be a right triangle? No, it won't be a right triangle either. So we're left with 4, negative 1. 4, negative 1. And this definitely is a right triangle. Okay. A right triangle has a 90-degree angle right there. Okay. So that would be choice C. And to find the area, base times height divided by 2, right? So the base of this triangle here we can have from A to B would be our base. 1, 2, 3, 4, 5, 6, 7. The height of the triangle would be 1, 2, 3, 4, 5, 6 times 6. 7 times 6 divided by 2, 42 divided by 2, or 21 units squared. Okay. I connected dots, and what did I make? I make a triangle. All right, I made a triangle. I actually made a obtuse triangle, okay, to be more specific. Obtuse triangle because it has an obtuse angle right here. This angle is greater than 9 degrees. Okay. It's a triangle. How do I know? Well, it has 3 sides, right? So it's a closed figure with 3 sides. Okay. Did I ask for the area? Yes, it asked for the area. So to find the area, well, base here would be this guy right here. From here to here is your base. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, base times height divided by 2. And the base is 9. And the height, careful, the height is the distance from this guy here. So imagine you're here, and you went all the way up here. So it'd be, I draw that line. So that's your height. 1, 2, 3, 4, 5, 6. Okay. Height's never a diagonal line. It's a straight line, right? So if you were over here and you drew a line all the way up, straight line, that'll be your height. So 9 times 6 is 54 divided by 2, 27 units squared. Okay. Point C. Okay, so here I went ahead, it said A and B was graphed, right? And then plot and label points C and D to form a parallelogram with height of 6. So to have a height of 6, I went 1, 2, 3, 4, 5, 6. So D and C wasn't there before. So I counted 6 for my height, and I chose 2 points to create a parallelogram. I chose point C over here, okay, first, and then to choose point D, well, it's literally how did I go from B to C? Well, I went 2 over and 6 up. So from point A, I'm going to go 2 over, 1, 2, and 6 up, right? So 1, 2, 3, 4, 5, 6, and then 2 over would give me 2, 8. So if I had to walk from D to A, I would go 6 up and 2 to the right. If I had to walk from C to B, I would go 6 up and to the right. So I know this line and this line are parallel. Okay. You could have made it differently. You definitely hear a lot of choices. So as long as your height was here, you could have made this a parallelogram. Let's say you chose over here would be from point 8. How would you get there? You would go 1, 2, 3, 4, 5, 6, and then 6 up, right? And if you drew a line, so you make sure that you from B to this new point, you would go 1, 2, 3, 4, 5, 6, and 6 up. And that would be your parallelogram, right? If you didn't like. So this one was open, right? So this, some of you could have done this, okay? So I chose this parallelogram, okay? So what's the area? Well, area of parallelogram is simply base times height, right? So let's count the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the height's obviously 6, or 72 units squared. Okay. Maybe I should have done the drawing first. All right, so draw a trapezoid with height of 5 units and a base of 3 units. So what you had here was this, A and B, nothing else. So you had to draw a trapezoid. So I chose just a simple trapezoid. The height had to be 5. So from B I counted 1, 2, 3, 4, 5, and that's how I decided on my C. Now, D, I chose D to be there. D could have been here, D could have been here, D could have been here. Okay, so some of you might come up with a different trapezoid than mine, and it's completely fine. Okay, so as long as it had a height, 1, 2, 3, 4, 5, and you needed a base here, a base of, what do you call, 3 units. So from the distance from C to D, this base that wasn't there, is it 3 units? It's 1, 2, 3. There. So that's what you were required to do. Create a parallelogram, trapezoid, the height of 5, and one of the bases 3. Again, height, B1 plus B2 divided by 2. That's how we find the area. So the height is 5, of course. One of the bases, the top one, base 1, 1, 2, 3. And base 2, which is the distance from A to B, would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then divided by 2. 9 plus 3 is 12. And then we're going to multiply that by 5 and then divide by 2. 5 times 12 is 60. Divide by 2. And that's going to give us 30 units squared. At least that's my trapezoid. Okay, so you could have done a trapezoid where it looks like, so let's pretend draw one, clear this, so draw that again. You had A and B, okay, that was given to you. So this is A, pretend you start with B. So you could have drawn another trapezoid that looked like this. Instead of, well, you have to count 5 up. So 1, 2, 3, 4, 5. That's your height. So you could have, let's say it shows point C over here, and 1, 2, 3, point D over here. So your trapezoid could have looked like this. Okay. The height's the same. So height is 1, 2, 3, 4, 5. Okay. That's okay. So we have both the same height, and the distance here between C and D is 3, and notice that the same distance here from D and C on mine is 3. So both these trapezoids would have been correct. And my battery's dying. Okay, so alright, so I wish I didn't do this. So what you had here before, what you had point A and B. Okay, and they told you that this was a diagonal. A and B formed a diagonal. Formed a diagonal of a rectangle. So you had to come, if that's diagonal of a rectangle, you had to come up with point C and D to form a rectangle. Well, if that's a diagonal, the other diagonal would have gone like this, right? And that's how I got my point C and my point D. So here's my rectangle. Okay, here's my really ugly rectangle. Okay. And to find the area, again, it would be just this times this, right? Length times width. Let me just clear this up. Good. Be 1, 2, 3, 4, 5, 6, 7, 8. And up is 1, 2, 3, 4, 5, 6, 7, 8, 9. So area, base times height, that gives us 72 units squared. Okay. A scholar plotted points. A blah blah blah. They determined that they plotted square. What errors did they make? Well, let's see. In order to be a square, all sides have to have the same distance, right? All sides have to be the same measure. So let's count this side here. This side would be 1 squared, 2, 3, 4, 5, 6. It's 6 units this way, which means here on the top is also 6 units, right? And which would imply that this and this would also be 6, but they don't look like it's 6. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units. And this is obviously 8 units as well. So you can write that, you know, they probably, they went 2 units too high here and 2 units too high here when plotting this particular square. They could have gone, should have put the points over here and over here, and that would have created a square. Okay? But it's obviously not a square because not all the sides are equal. Use a diagram. Use a diagram for something to find the width, right? So the width is this. So it's very easy to count from here to here. It's just 2 units, which makes this guy over here 2 units. Excuse me. And the width, that'd be the width here. This is the width. Then the length would be from here to here. You can go 1, 2, 3, 4, 5. 10. What is the distance around the swimming pool? So, what if you're not asking for area? So that's 5, and this is 5. So if you were here and you had to like run around, okay, or what would be the distance around the swimming pool? Well, you would walk 5 here, 2 here, 5 here, 2 here. So it would be 2 plus 2 plus 5 plus 5 gives you a total unit of 14 units. Not square, just simply 14 units. Okay. The next question. If Ben wants to place orange cones around the swimming pool every 4 feet, well, I'm assuming each square is 1 feet. The problem never said that each one measures 1 foot. So every 4 feet, how many cones will he be able to place? Well, let's see. Let's start. Let's not start there. So let's count. Well, let's start that corner. Okay, so we start here. 1, 2, 3, 4. There's a cone. 1, 2, 3, 4. There's another cone. 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 1, 2, 3, 4. You can put another cone, and then 1, 2. So you would only be able to put 3 cones. Remember, because we started in this location, right? 1, 2, 3, 4, cone, 1, 2, 3, 4, cone, 1, 2, 3, 4, cone, and 1, 2, you can't put any more now. Okay, so you put 3 cones. Silly question. What is the area of the shape below? So notice that this you don't have a coordinate, you don't have a grid. So I'm gonna have to do a little thinking here. So let's start here with the width. The 19th is 19th, so imagine they being on the x-axis. So they're both on negative 19, okay, to the left. One is 12 floors above the x-axis, and the other one's 10 floors below the x-axis. So what's the distance between negative 10 and 12? So if you were on negative 10th floor and you had to go all the way to the 12th floor, how many floors would you travel? Well, from negative 10 to 0 would be 10 floors. And then from 0 to 12 would be 12 floors. So you would travel a total of, and you add these two, 12 plus 10, 22 floors. Okay, to go from negative 10 all the way to 12. So this would be 22 floors. Distance here on the distance here. Okay. Now you would measure, well, they're both on the y-axis, they're all the way down on negative 10, but one is 19 to the left and the other one's 21 to the right of the y-axis. Okay, so imagine here, one is over here at negative 19 and the other one's over here at 21. They're both on negative 10, right? But one is left 19, the other one's 21. So imagine if you were here and you had to walk all the way to 21. Well, from 19 to the y-axis, you would take 19 steps, right? The absolute value. And then from the x-axis to 21, you take 21 steps. So at this distance, with this distance, 19 plus 21 gives you 40. So that would be 40. Okay, now that you have the measurements, to find the area of a rectangle, simply base times height, or length times width. So it would be 40 times 22. And that would be, I have no idea. I don't know why my pen's not working. Okay, here we go. 880 units squared. Okay. Given the line segment A and B, create a shape that has an area of 48 square units. So this is what you started with, just A and B. Okay. A and B, that's all you had. So you had to create something, and I created something very simple, not just a rectangle, was 48 units squared. So I knew that this was 1, 2, 3, 4, 5, 6 going across, and to make something that had 48 inside, I had to go 8 up, because I know that if I multiply 6 here and 8 over here, I get 48. And I form, and I go 8 up, 1, 2, 3, 4, 5, 6, 7, 8, and that's how I created my point C, and my point D. And inside this particular shape, there are 48 little squares. You could have made any other shape. Doesn't necessarily have to be a rectangle. Okay, yeah, could have made a, I don't know, could have made a triangle if you wanted to, a trapezoid if you have more creativity than I have. Okay, but rectangle serves its purpose just fine. Create an obtuse triangle. Okay, so here I'm going to actually, with a unit of 6 and a height of 4. So you have nothing. So I'm going to tell you what I did. So let me pick this one here. I count 1, 2, 3, 4, 5, 6. So this is my base of my triangle, 6 units. I had to create something with obtuse. So remember, this is a 90 degree. This is 90 degrees, right? This is an acute angle, right? Because it's less than 90 degrees. And an obtuse angle, something that opens much wider. Okay, so anything that opens less than this, okay, is an acute. And when this opens that way, okay, you can create an obtuse angle which is greater than 90. Okay, so I had to create something that was it had a base of 6 and a height of 4, and it has to be obtuse. So I created that. So to have something that had a 4, so let me just count 4 up. 1, 2, 3, 4. So the height should have been at this level. I'm going to draw the line over here. This line. Anything on this line. Okay, so you can see that I created that one over there, but I'm going to create a different one over here. Put this dot right here. Join and join. Now, does it have a base of 6? Well, 1, 2, 3, 4, 5, 6. Check. Does it have a height of 4? So from this guy right here, if we were to drop a ball all the way to the floor, and the floor is where the base is, would it be 4 units? Well, 1, 2, 3, 4. That's 4. Check. So whether you do this triangle or this triangle, either of them satisfy that condition. Okay. And were you asked to find the area? You weren't. Okay. So that one you had choices. Okay. Open-ended question. Okay. Nice. And I think that's that for this one. And I think there's one more. Oh yeah, this one, the exit one. So this one I'm gonna have to do. So I'm gonna draw a trapezoid and find the area. So that's the first thing. Okay, so -5 and 5. -5 and 5 would be about here. Call it A. -5 and -3 be here. Call it B. C is 4, -3, 4, -3. And D, 0 and 5, 0 and 5. Does that form a trapezoid? Well, yes it does. Trapezoid is base height, B1 plus B2 divided by 2, and that's how we find the area. So let's find, here's my B1, right? Here's my B2, and my height, this is a straight line, right? That would be my height. So B1 is going to be 1, 2, 3, 4. B2 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. My height is going to be 1, 2, 3, 4, 5, 6, 7, 8. And we're going to divide all that by 2. So 4 plus 9 is 13. We'll multiply that by 8, and then we'll divide it by 2. And 13 times 8, 24 goes to 104. And we're going to divide 104 by 2, which is going to give us 52 units squared. Okay, so we did that, find the flip to back, and we're going to do this. And what we're going to do is obtuse triangle. What's the area? Right, so let me see if I can make this smaller. Yeah. So, point A is -2 and 4, -2 and +4, so we go up. Point B is 0 and -2. So we need to come up with another point in order to create an obtuse triangle. Well, you can already see some of the triangle coming to shape here. I'm going to draw a straight line in this thing. So there you go. So there is one line, right? So to create a triangle, well, you can make this, extend this as far as you want. It could have been smaller. I'm just going to make it all the way here. So that's going to be, and I chose that, my point C. Now connect A to C here, and you can definitely tell that I have an obtuse triangle. And none of that is what I wanted to do because that's not what they asked me to do. Okay, so A, -2 and 4 is here. B, 0, -2, right here. So already A, B, C. Is it A, 2 and 2? 2 and 2 would be here. Nope. Is it B, 4, -2? 4, -2? Ooh, yeah, look at that. If I connect these, do I have a triangle which is obtuse? Yes, this angle here is a little bit more than 90, so B works. Okay, so just to see if this C works, 0 and 4, 0 and 4 over here. No, that actually gives us a 90-degree angle triangle, a right angle triangle, and -2 and 2, -2, -2. It also wouldn't work because that is a right angle triangle. So the one that we won was B. Okay. We have to find the area. What is the area? So we do. So let's do this again. 0, -2. Why did I move it? Right there. So 0 and 4? No. Let's see. 4, -2. 4, -2 right here. That's our triangle. Okay. So A, B, C, base times height divided by 2. Our base is this from A to B, so that's 1, 2, 3, 4. Our height, and again, our height is not this and not this, not a diagonal. So you're going to drop that. Pretend you're standing on top here, and you're going to drop a line all the way to the floor. Be 1, 2, 3, 4, 5, 6, all the way to 6. That's our height. And here, that's our height. And we're going to divide it by 2. 4 times 6 is 24. Divided by 2 equals 12 units squared. So let me just make this a little prettier. Okay, so our point was -2 and 4. 0, -2. And the other one was 4, -2. So that was our triangle. Okay, and the height is this guy right here. Draw it down. Okay. There's our height right there. Okay, this distance is our height. Okay, and that's it, I think. Yes, no, yes.